Alright, the 45, 45, 90 special right triangle. And we're going to do example 16 from the back of the homework. So, a little bit about the 45, 45, 90 special right triangle. So, if we take a square, horrible square, make it big. A little bit. Alright, so we take a side length of x, and if it's a square, all the sides will be that length x. And if we take a diagonal from one vertex to the opposite vertex, you get a hypotenuse opposite your right angle. And the diagonal bisects the right angle, so we have 45 degrees on either side of the right angle. This hypotenuse is x square root of 2 as far as its length. It's a little bit longer than the sides of the square. Now, removing the excess square, we have our special right triangle. So that's where it comes from. How do I know x square root 2 is the rule here? Well, we'll use our Pythagorean theorem. Okay, we'll substitute the legs. X is a leg there, this is a leg, and this is our hypotenuse. Alright, so we're going to have x squared plus an x squared equals the c squared. We know the hypotenuse. Combine the x's. 2x squared equals c squared. Square root both sides. We're left with c. And square root of 2 times the square root of x squared, which I'm writing smaller and smaller, reduces down to square root of x squared is x. Square root of 2 can't be simplified. And we get x square root 2 for our c hypotenuse, which is our rule right there. Okay, so that's where the side lengths come from. And we'll use these rules as a template for solving the chart on problem 16. Alright, so on problem 16 we have side lengths, or the legs, as x. So I'll just label this. And our y value here is the hypotenuse. Alright, so here in the top row is your x's, the bottom row is your y's. So this first column, your x is 5, which means both legs are equal to 5. Now, your hypotenuse has a rule of x square root 2. And if x is equal to 5, you simply substitute your 5 into the x. So now we get 5 square root of 2, which is the length of your hypotenuse. No way of putting it is that your hypotenuse is your leg times the square root of 2. Alright, so since the leg is 5, multiply square root of 2 to it, we get 5 square root 2. Alright, so let's try the next example. Now this example is telling us that our hypotenuse for y is equal to 4 square root of 2. Now our rule for hypotenuse, x square root 2, is here. And just like when we substitute the 5 for x, the 4 in front of the square root 2 is our x value. These go together. So we get a side length of 4 for our legs. Alright. If you want to do this algebraically, take your rule x equal to for square root of 2. Divide x square root 2, the rule for your hypotenuse, set it equal to what you got. Divide both sides by the square root of 2, and you cancel out that. These two cancel out, your x equals 4. Alright, so setting your rule equal to the side that you have will get you an algebraic equation you can then solve for your unknown. So there's the algebraic way of solving for that as well. But I think it's much easier knowing that the number in front of the square root 2 is the legs of your 45, 45, 90 right triangle. Going on to the next problem. Each leg is a square root 2 length. Alright, so again, the rule for the hypotenuse is x square root of 2. Alright, now, just like we did with the 5, we're going to take the square root of 2 and substitute it into that x. Alright, so then we get square root of 2 times the square root of 2. Again, this 2 went in for the x value. Square root 2 went in for the x value. Now the square root of 2 times the square root of 2 is just 2. So we get a hypotenuse of 2. Alright, so we have 9 in the next column. X equals 9. So the legs are 9, which means we just simply put 9 and multiply the square root 2 to it. And we get our hypotenuse. Alright. The last column is a challenge because now we have a number that doesn't have a square root in it, 24. But the square root 2 is inside the 24. And again, the rule for the hypotenuse just set the two hypotenuses equal to each other. So we have 24 is equal to x square root of 2. Solve for x by dividing the square root of 2 to both sides. We get x. Now, since there is a square root 2 in the denominator, we must multiply both the numerator and the denominator by a square root of 2. Then we get 24 square root 2. Square root 2 times square root 2 is just 2. Now 24 and 2 reduce, and we get 12 square root 2 equal to x. And that would be our answer for the last column.